I'm Mr. Storm here for video homework 2. So our first question we have here is as detailed. It says a used car dealership collected data on the selling prices of cars and their ages and years. Based on a sample of cars of the same model, the least square regression line for predicting price from age and years is as follows. Its price equals 18,000 minus 1250 multiplied by age, or your depreciation over time. So number one, we have slope out the relationship between prices and car age. So from the slope, we can tell it's going to be negative because of this minus sign, because over time the car is going to go down in value. So that answers slope, it's going to be negative. And then number two, we have the predicted price when the car is 0 years. And how do we interpret this value? So how we solve that is we plug 0 into the age x, pretty simple. So we would do 18,000 minus 1250 times, got times up by 0. So that equals 18,000, obviously, because this will just cancel out. So it leaves us 18,000. So when the car is 0 years old, it's going to be worth $18,000. Okay? Then number three, predict the price of a car that is 5 years old. So same thing. I'm going to multiply that. 18,000 minus 1250 times 5. It's going to get us 11,750. So that's the price of the car whenever it's 5 years old. All right, so for number three, we're predicting the price of a car that is 5 years old. So for this one, we're just plugging 5 into the age box. So when I do that, I would do 18,000 minus 1250 times 5, that's the age we're looking for. I'm going to get 11,750. So that's for three. And the last one, number four, does it make sense to use this model to predict the price of a car that's 25 years old? Yes, because it's going to depreciate over time, so it worked for the equation. So for number one, I asked us to make a scatter plot. So we base the values of the scatter plot off this table right here. So these all align with the points in here. And so that's scatter plot number one. Number two, ask us, would you use the regression line to predict y from x? Yes, you would if it's between 20 and 80. So it matches the values in this plot, but if you use anything over 80, wouldn't work, anything under 20 wouldn't work. So that's number two. Number three asks us to verify the value of the first residual for x equals 20 and verify if residuals have some 0. So we're going to use this formula. So we have 70.243 minus 0.329 times 20. That gives us 63.663. When we plug that into our residual formula, we get 49 minus 63.663 equals negative 14.663, which is congruent or equal to negative 14.67. So that means that it does match and that therefore this does work. Our last one is number four. So we've made our regression line here and we get the answer that both plots do tell the same story and that their model bends the wrong way and that the data curves away from the line. So that's what you can tell based off from part A of the question. All right, so we're on question 3 now. So it's 1 and 2. So question 1 asks us to sketch the Venn diagram. So it's sketched here. You have A, B, C, and D, just your different scenarios. And then D is encompassing it all. So for number 2, we have what is P of D that an employee will leave within a year. So what's the probability of that? So we look at this and we find the answer is we add wherever A, B, and C overlap with D. So we have it overlaps by 0.1 here. Overlaps by 0.1 over here as well. And then for C, it overlaps by 0.2. So you take and add all those probabilities, and we end up with 0.1 plus 0.1 plus 0.2 equals 0.4, or probability of 40% chance that an employee will leave within a year, and that's the answer to the question. All right, so last problem, problem 4. We have our table listed out here. Females and males, and associates, bachelors, masters, and doctorates. They with our totals on each side. So we're going to use this to find all the answers to these questions. So we have number 1, asking us, what's the probability that it's a man? So we're looking at our table. We're going to go over to male. We see that total males, everybody here, we have 1,657. Now it asks us to ask, and now it asks us what's probably that's a man throughout the whole entire table. So we're going to look at the total. So females and males, you have 3,990 people. So we're going to divide 1,657, which is our males, divide that by the total number, which is 3,990. So I'll write that out here. So 1,657 males divided by the total amount of people we have, which is 3,990. And that is going to get us 0.415. So it's going to be roughly 41 to 42%. So that's a probability that we have for a man for number 1. Now we go on to number 2, we have same thing, but it's conditional probability. So we have that it's a man again, but given that they have received a master's. If you look at our male column again, we're just looking at masters this time, and just the master's column because it's conditional probability. So we would take 340 this time, that's how many males have received the master's, and we're going to divide that by how many people we have that do have a master's, which includes the females. So that'd be 813. So when I compute that out, I'll do 340 divided by 813. That gets me 0.418 or 42%. It's roughly that. Okay? And then number 3, we have all the events, choose a man, and choose a master's degree, independent. How do we know? So to know this, I'm gonna have to see if these two probabilities match, okay? So I'm gonna look at this, I'm gonna do 0.415 for a man, the probability. I'll multiply this by the probability of a master's, which is 0.204. And you find that by dividing 340 by this, it's the amount of people. So when we do that, we multiply those two together, and we find that when we do that, we do get 0.085, which probably puts a man and a master's, so it matches. But I'll do this out anyways just to make sure. So I'll do 0.415 times 0.204, and we get 0.085. That's the answer.